Hi, I'm Stephen Daniels,
And I'm Matthew Hatch.
and today we're going to be demonstrating people detection using a 60 gigahertz millimeter wave radar.
Why millimeter wave radar? So, millimeter wave radar has a wide range of applications while being low cost and easy to use. It's heavily used in the automotive industry for virtually all collision warning, avoidance, and self driving applications. Industrial applications include collision avoidance and spatial awareness for robotics, room occupancy detection for smart lights and HVAC, and pedestrian traffic monitoring with people counting. As you can see in the diagram on the right, there are many other applications of millimeter wave radar. Millimeter wave radar is a type of radar that operates in the millimeter wave band of the electromagnetic spectrum. Frequency modulated continuous wave radar repeatedly transmits a tone of linearly increasing frequency. Each frequency ramp is called a chirp. Energy is reflected off of targets and collected by the receive antenna. The received signal is then mixed with the transmit signal at that instant, and the result is digitized for further processing. The difference between the transmit and receive frequencies within a chirp is used to determine range to the target. The difference between the signal phase at a particular frequency between chirps is used to estimate the velocity of the target.
Project goal. The main goal of our project was the production of a range Doppler map, which is a visualization of the targets in the field of view of the radar. The plot shows the targets in both the range dimension, which is the distance to the target, and the Doppler dimension, which is how fast the target is moving relative to the radar. An example of the range Doppler map can be shown to the right, and ideally, we would like to clean up the range Doppler map so that there's less noise using clutter reduction and target detection algorithms. If time permits, we'd also like to use multiple transmit and receive antennas on the radar to estimate the angle of arrival to the target and the elevation of the target to show its position in 3D space. Hardware overview. For this project, we chose the IWR6843AOPEVM antenna on platform, which is a solution provided by Texas Instruments that provides an all-in-one millimeter wave system, which includes the RF front end, DSP and hardware accelerators for signal processing, and all the interconnects between the board subsystems and a host Windows PC. In addition to the main radar board, there's also a carrier card called the Millimeter Wave IC Boost, which provides a JTAG debugger for development purposes, and a DCA 1000 capture card, which adds the ability to stream or record raw samples from the ADC on the RF front end. We'll now show a real-time demo of the radar system in action. On the right side of the screen, you'll see the range Doppler map being created in real time, which shows the energy returned from the targets in the field of view of the radar, which will be Stephen and I. The interesting thing on the range Doppler map will be to focus on the orange and yellow sections of the map, which show a high amount of energy being returned. As you can see, there are two targets clearly in view of the radar. Both targets are moving opposite directions towards and away from the radar, and so they show up on opposite sides of the Doppler axis on the radar, with the positive Doppler axis showing motion towards the radar and negative motion away from the radar.
One of the primary objectives of our project was to have an accurate measurement of range. This diagram shows that FCW radar with range resolution cells. Our range resolution was 10 centimeters, which means that we want to be able to detect two targets separated by a minimum spacing of 10 centimeters. Now we will demonstrate our ability to separate two targets 10 centimeters apart. So what you're observing is me trying to measure 10 centimeters using a tape ruler. And what you can see is that Matt and I spaced 10 centimeters apart can be indicated in the range Doppler map, which says that we met our resolution requirement. This can clearly be seen by the fact that there are only two bright yellow responses that show up in the range Doppler map, even though Matt is only 10 centimeters behind me. To summarize, we have demonstrated the ability to capture a frequency modulated continuous wave, process this data, and produce a range Doppler map which demonstrates our ability to detect two people closely spaced in range at a certain velocity. Thanks for watching.